Hey, what's up everyone? Welcome to this new live stream where we're going to talk about a line of code that, especially if you've been writing programmatic UI kit code, you are probably very familiar about. So let me show it to you. It's this line right here. So view.translates autoresizing mask into constraints equal false. If you do programmatic UI kit, you've probably been into the situation where you've forgotten to write this line of code, and as a result, your UI didn't behave as you expected. And sometimes you don't realize you've forgotten this line, and you spend quite some time, maybe half an hour, 1 hour, 2 hours in the worst case, I've probably done it, trying to understand what's going on, only to realize that this line is missing. And when this line is not here, for some weird way, your view behave in a different way. It's like if some extra behavior had been added to your views. But at the same time, this line might seem quite mysterious because what this line mentions, so this auto-resizing mask, if you've been doing iOS since after iOS 6, I think there is a good chance that you've actually never had to use an auto-resizing mask. There is a good chance that you saw it in Xcode when using Interface Builder, but you might not have realized that it was actually an auto-resizing mask. And so my goal for this live stream is to basically explain what's behind this line of code, why did it come to exist, why is it like such a trap for iOS developers. And for that, we're going to deep dive into how UIKit lays out views, so using Autolayout, but also into the solution that was there before the existence of Autolayout, because Autolayout was introduced with iOS 6, if I remember it correctly. It was when the iPhone 5 was introduced, and it was the first iPhone to have a different form factor and a different aspect ratio for the screen. Before that, we didn't need any kind of constraints because there was only one size of screen, and so content could be placed just by using pixel coordinates. However, you still needed a way to resize your UI for when the view would go from portrait to landscape. Landscape was much more fashionable in the early days of small screen iPhones, and so that's what this auto-resizing mask used to handle. So the way we're going to explore this topic is that I've picked an article that I found that looks really interesting. So let me switch to the other scene. So you can see the article. It's called Autolayout versus Autoresizing Mask in Swift. So it's on the blog Advanced Swift, and you have the link in the description if you want to go over it at the same time or after. And the plan is that we're going to go over this article, reproduce the code in Xcode, and basically try to understand what the hell is this concept of an auto-resizing mask. Last thing, if you are watching live, don't forget, first of all, if you're watching live, thank you for being here, but also don't forget that you have a chat. So any questions or remarks that you have, please ask them in the chat. As always, I'll do my best to answer them. And by giving your questions and your remark in the chat, you are probably voicing the same questions and remarks that people watching the replay are having. So you're giving them a voice, which is super cool. So let's get started. So we're going to learn when to use Autolayout and Autoresizing Mask to create responsive user interfaces in Swift. Actually, what we can do is that if you have ever used an Autoresizing Mask in Xcode, let me know in the chat. And if you've ever used one since Autolayout has become the default solution, also let me know, because it's an even more rare, I'm not sure you're supposed to say it, but an even more rare use case. So user interface layout programming is a big part of modern iOS and macOS apps written in Swift. Of course, this article, you can see, it's from 2021. So Swift UI was already there, but not as popular as today. So this post presents a brief overview of two layout methods, auto layout and auto resizing masks, and contains example of how each method can be used in Swift. So we're going to see what Autolayout is, even though I'm sure that you already know, but it's always good to see it, to have it like fresh in your mind. And then we're going to see what these auto-resizing masks are and compare them with Autolayout. So Autolayout. What is Autolayout? Autolayout is a user interface layout framework that uses constraints, a rule for where a UI element should be, to determine the layout of a UI. The Autolayout engine will recompute the appropriate layout when the super view changes size. For example, when the user resizes a window on macOS, an iOS device rotates, the user enters or leaves split view on an iPad running iOS. Or even other cases, like for instance, when you, I don't know if it's still the case, but it used to be that if you are using an app with an ongoing call, you would have a small bar at the top of the screen. Now I think it's no longer the case, but it also used to be the case. So auto layout example. One common use case for auto layout is supporting rotation, so UI adapts appropriately to landscape and portrait device orientations, and also adapting more generally to all the different kind of device sizes that we have out there these days. So to use auto layout on a view, that view needs a complete set of constraints. This means that the view's axis, Y, width, and height properties must have constraints defining how each of those frame properties should be computed. And actually, auto layout under the hood, it's nothing else than a system of linear equalities or inequalities that gets solved and in order to provide values for the variables. And these variables are x, y, width, and height, because you need 4 variables in order to draw a rectangle on screen. So in this example right here, so to make a UI label and UI text field responsive, meaning that it will respond to changes in the parent view size, the following constraints will be added. So top space to the super view, leading space, so here in this case on the left, to the super view, trailing space to the super view, bottom space to super view, and also a height constraint. So we can see these constraints being set in Xcode. So if you've ever done this, you were using Autolayout, but I'm sure you were already familiar with this. So this is how you create Autolayout constraints using the graphical interface in Xcode. So adding the constraints in a storyboard to the UI label shows the blue constraint attributes when the UI label is selected. So here we can see the visual representation of the constraints. The same type of constraints were added to the UI text field underneath. And so the UI label and UI text field are now properly constrained using Autolayout. When the UI orientation is changed to landscape, Autolayout will expand both views horizontally, because we have enough constraints so that given the frame of the parent view, the frame of each child view can be determined. Okay, now it talks about Autolayout safe areas examples. So a superpower of Autolayout is handling safe areas. So the area in which it is safe to draw your view. Quick recap, safe areas, they were introduced, it's a concept that was introduced with the iPhone 10, because since it no longer had the home button, you would swipe to go back to the springboard, and so there was a need to have some places in an app where you shouldn't put components that the user needs to interact with or read, because there is the bar at the bottom. At the top, there is the status bar now being displayed. And so this was implemented through this safe area concept. So that's what they say actually. Safe areas are margins maintained by the iOS system to help user interfaces account for system attributes. So a safe area is just margins that are added into the super view. For example, safe areas can be used to handle rounded corners and non-rounded corners on iOS. Because when you have a screen with a rounded corner, it means that part of what's being displayed is being cut off, and you don't want to display important or even any information that makes sense into this part that can be cut. It's okay if you have like some plain color because there's no information there, but you don't want to display some text that could have its beginning being cut off. So the secret to handling safe areas is, sorry, I need to move a small window. Perfect. So the secret to handling safe areas is a view constrained by Autolayout does not need to be constrained only to its super view. In the following example, the inbox UI label will be constrained to the top safe area of the UI view controller view, even though the super view of inbox UI label is the view with a blue background. So basically, you can access the safe area using a constraint, even though the view is not directly at the top level. Every child view has access to the safe area margins, and indeed, it's one of the things that makes the safe area quite powerful and quite easy to implement. So the first step is to constrain a view with a blue background to the leading top and trailing edges of the super view. So here, it's this view right here in blue, and this view completely ignores the safe area. All right, and do not constrain the bottom or the height in this step. I guess we'll see why just after. Then you add QUI labels with some text. You add constraint for the leading and trailing edges of the inbox UI label to the super view. So the super view being the blue view, so the view with a blue background. And you also add a height constraint to the inbox UI label view. So this one right here. Once again, you do not constrain the top edge of the inbox UI label at this step. For the subtitle UI label, you add constraints for all edges to the super view. So constraint to leading, trailing, bottom, and then top. Even though in that case, the top, it's not the super view, it's the view above. So it's the inbox label. So far the views added are not yet fully constrained because there is no way to know where the inbox should be positioned for its vertical position. This next step completes the Autolayout configuration and provides the desired behavior. So we're going to constrain the inbox UI label to the top safe area of the UI view controller view. So it's a case of using the control click in Xcode and to constrain it to the top space of the safe area. And what's important to understand here is that this works even though the label is not at the top level. So the label is in a view, the blue view, which itself is not constrained to the safe area. However, a child view inside the blue view can be constrained to the safe area, which, as it was saying before, is quite a powerful feature of safe areas. So this result below shows the powerful capabilities of your Autolayout. Now, across different devices with and without rounded corners, the UI will display correctly, meaning that when you have a borderless phone, you can see that inbox appears below the notch or now also below the dynamic island. But when you have an iPhone without a notch or a dynamic island, then you can see that the UI label inbox appears closer to the top because in this case, there is no safe area or it's much smaller if there is one. Now, autoresizing mask. So now let's get into the part that I guess most of you are not familiar with. So what is a autoresizing mask? Autoresizing masks is a layout method using a bit mask or an encoded set of flags. So think about option set in Swift. It's the kind of values. A bit mask is basically when you have an enum and you want to make the cases of your enum combinable. So you don't want them to be mutually exclusive. You want to make them combinable. And the way to implement it is to use a bit mask. So to represent with one bit, for instance, the first case would be 1. Then the second case will be 1, 0. The third case, 1, 0, 0. This kind of thing. This way, you simply need to do a logical OR in order to mix all of the cases into one value. And then you can read from it by doing a logical AND in order to know if a given flag has been set. And so this autoresizing mask, so it's a layout method that uses bit mask that defines how a view should respond to changes in the super views bound. So this is the system that was in place when iOS first launched. So the properties available in a auto-resizing mask on a view are flexible top margin, meaning resizing can change the view's top margin. Flexible left margin, so resizing can change the view's left margin. Same for right and bottom. You can notice that it says left and right and not trailing and leading. And that's because Autolayout has a nice support of right to left languages because it can then switch leading to right and trailing to left. However, Autoresizing mask did not have this support, and left and right were hard-coded. And I see Remelt in the chat saying, this brings back memories. I had Autolayout mask set up correctly in an app, so when the iPhone 5 released, it just worked. And indeed, it would have still worked. You had less possibility than with Autolayout because resizing mask is a more simpler approach. It doesn't have it doesn't contain the power of solving a linear system, which is quite powerful. But if you had done it correctly, indeed, it was supposed to work on the iPhone 5, which was the first iPhone which offered a screen that was taller than all of the other models before. Because the original iPhone, the 3G, 3GS, had the same resolution. 4 and 4S had twice, either twice or 4 times as many pixels. I think it's 4 times, but it was still the same aspect ratio. It was just more higher density of pixels. So a UI that was positioned using hard-coded pixel positions would still work in the iPhone 3G and the iPhone 4 because it was still the same coordinate space. And for the iPad, back then, all of the iPad also had the same 4/3 aspect ratio. So it was also the same thing. So we have this flexible top, left, right, and bottom margin, and flexible width, that meaning that resizing can change the view's width, and same thing for the height. Indeed, we had pixel perfect design, and also, just to go back down memory lane, you need to remember that the original iPhone was, more like the original iPhone 3G because it was the first one that you could officially develop apps for with the App Store. It wasn't super powerful, and typically transparency effects were quite costly. So what people used to do back then, since there was only one screen size, is that they would render their UI on Photoshop, export it, put it as a background image, and then they would put all of the UI components over this, but transparent. And this way you could get some very pretty UI with some really nice visual effects, but they had all been pre-computed because there wasn't enough compute power to have something that was beautiful and also power efficient and CPU efficient. It was really another time. Also, if you had really complex views, sometimes even like xibs. So there wasn't storyboard, but you had the xibs, which were you can see a xib as a storyboard of one screen, give or take. In the most complex cases, also they would take too long to deserialize, and so you would need to have more custom approaches in order to handle really large amount of UIs. Typically, people that were doing digital publishing, they had to rely on this kind of systems in order to scale. So let's see an auto-resizing mask example. And maybe you're seeing this part right here. So when I told you that there was a good chance that you had already seen an auto-resizing mask without knowing about it, I was referring to this little thing in Interface Builder in Xcode that you might have noticed at one point or another. But let's take things in order. So this auto-resizing mask example will define the layout of all subviews in a chat message cell using auto-resizing masks. First, we add all the 4 views in the parent view without any constraint. So you just drag and drop them into a storyboard. Then, in the size inspector, you configure each view with the appropriate resizing mark. Each red and faded red arrow or strut in the Autoresizing section of the inspector is clickable. So you can click on this thing, and on the two arrows. What's interesting is that, so these are struts, these are arrows, but if you look at articles and video from back then, the arrows will often be called springs, and this was referred to as springs and struts. You might find this terminology if you look at old articles. Clicking on a red or faded red component will enable or disable the auto-resizing mask property. So the advanced Swift UI label here, so in this example, it has a flexible width shown by the red horizontal arrow and a fixed leading top and trailing margins also showed by the red top and right struts. But it doesn't have a flexible height and it doesn't have a fixed bottom size. Then if we look at the date UI label, we can see that it's pinned to the top and trailing edges of the super view. And we can see that it's not expected to grow either in height or in width. And it's not also expected to keep its position with respect to the left and bottom edges. And you can see that the logic is kind of similar to constraints. And we can really see in this example that it's similar to a simpler set of constraints. In a way, it's similar to constraints that are only set with the super view, in a way. I'm sure that this is not exactly true, but I'm also sure that you get the idea of what I mean. Then for the message UI label, you can see that it has flexible width and a left and a right. It's pinned to the left and the right and also the top. And finally, the A UI label is pinned to the top and the leading edge, so it's kind of symmetrical to the date label on the right. And so now, with all views configured with the appropriate auto-resizing mask, the view is responsive. In a landscape orientation, the advanced Swift and message UI label will be stretched horizontally. So you can see that between this example here and this example here, we have more horizontal space. It might be because the view went from portrait to landscape orientation. It might also be because we went from being on iPhone or on iPad. And so you can see that this label is still at the same position with respect to its left, top, and right coordinates. However, in terms of width, it was allowed to expand and to occupy more width. Let me see. So it is stretched horizontally with all other views staying the same size. The date UI label is maintaining its distance from the super view's trailing edge. So it's a design choice, of course. But the idea is that this system of auto-resizing mask was the first way of handling different screen sizes in a way that would respect how the UI should flow, we could say. Now the question about Autolayout versus Autoresizing mask. So when to use Autolayout? Although both Autolayout and Autoresizing mask can be used to lay out iOS and macOS UI, Autolayout is a more powerful layout framework. Use Autolayout for safe areas and margins, complex layout responsiveness, interview dependencies like aspect ratio related with, and fine-grained layout control. So we've seen that you can only use a safe area with Autolayout. We've also seen that with an auto-resizing mask, you cannot do a dependency between views. You cannot do things really complex, and you don't have a high level of control. You cannot set a given constant. It's a much more simpler approach. Now, what's interesting is that they also give some criterion on when to use auto-resizing mask. So just to give you my opinion, I have never used an auto-resizing mask in more than like 10 years, but UI is always a matter of like preferences. So if it works for you, why not? So even though Autolayout is more powerful, auto-resizing can still be valuable. Consider using auto-resizing masks for embedded views that primarily stretch in one direction, prototyping responsive UI, or simple layouts. Honestly, I would mostly go with prototyping, but the other two, to be honest, if you're working on a project that uses Autolayout, use Autolayout all the way, because having two different systems I'm kind of thinking that it's going to create more issues down the line to have two different systems rather than one. But for simple prototyping, it can indeed be useful because having to set complex constraints when you are prototyping is not the best. This can be a way to solve it. Now let's see. I'm just checking. Okay, we have one last chapter, and then we'll go into what does this property translates autoresizing mask into constraints actually does. So using Autolayout and Autoresizing mask at the same time. Autolayout and Autoresizing mask are not exclusive user interface layout methods, and both can be used at the same time. Both examples presented in this post are combined in the following example. First, a UI table view was added using Autolayout constraining the top, leading, trailing, and bottom edges. Then, the UI table view cell was added using Autoresizing masks as presented in this post. The result is a user interface layout that reacts as expected in both portrait and landscape orientations for devices with and without rounded corners. So we can see the code here. So all of this uses Autolayout, but everything that is inside the cell uses Autoresizing masks. And we can see that it adapts to landscape orientation. So that's it for this article, but we are not finished for this live. By using Autolayout and Autoresizing masks, individually or together, you can create responsive UIs for your iOS and macOS apps in Swift. Now, let's go into Xcode. Because what I wanted to talk about in this live is this property right here. And we haven't addressed it for now. But at least now we have a good idea of what Autolayout is. It's fresher in our mind. And we've also learned what an autoresizing mask is. So let's try to see what the doc has to say about this property. So there is nothing written when I do a command click, but if I do alt click, yes. Of course, it's going to appear outside of the screen, so I will need to open it in the documentation like this. All right, let me display it so it is visible. All right, so this property translates autoresizing mask into constraints. It's a Boolean value that determines whether the view's autoresizing mask, which has some default value when you create it, is translated into Autolayout constraints. If this property's value is true, the system creates a set of constraints that duplicate the behavior specified by the view's autoresizing mask. This also lets you modify the view's size and location using the view's frame bounds or center properties, allowing you to create a static frame-based layout within Autolayout. So it's a way to emulate the autoresizing mask system into Autolayout, which makes sense since Autolayout is more powerful than autoresizing mask. It's possible to emulate autoresize inside Autolayout. The other way around wouldn't be possible, of course. Note that the autoresizing mask constraints fully specify the view's size and position. Therefore, you cannot add additional constraints to modify this size or position without introducing conflicts. Here we get into the part of it explains why you can get into trouble if you don't set it to false. If you want to use Autolayout to dynamically calculate the size and position of your view, you must set this property to false and then provide a non-ambiguous, non-conflicting set of constraints for the view. Basically, you need to use Autolayout correctly. And now we get to the really interesting part. By default, the property is set to true for any view you programmatically create. If you add views interface builder, the system automatically sets this property to false. And that's it. Here you have, in a nutshell, the reason why this line is so confusing. So why this property is so confusing. This property was added in order to allow developers that either were familiar with autoresizing or that had code that relied correctly on autoresizing to reuse autoresizing within Autolayout. As we've seen, this property only does something when it's set to true. When it's set to false, it does nothing. It's a no-op. But the tricky part is that when you create a view from interface builder, so from a storyboard or from a xib, the system automatically sets the property to false. That's why if your views are created in storyboards, you've probably never needed to set this property to false. However, if you create your view programmatically, so by calling the initializer of UI view, UI label, UI button, any of these subclasses of UI view, then translate autoresizing mask into constraint is going to be set to true by default. And as we've seen, when it's set to true, you cannot add your own constraints. Otherwise, the constraints that are added by turning the mask into constraints and then your own constraint will conflict, and so your view will not be correctly positioned on the screen. So that's the reason why you need to set the property to false when you create views programmatically, is because by default, the property is set to true. I guess for legacy reasons, so that code that was created before the introduction of the property would behave like it used to. And if you don't set the property to false, then this autoresizing mask gets turned into constraints, and these constraints addition with your own constraint, resulting in conflicts and resulting in your view being displayed either at the wrong place or not being displayed at all. So that was it. It was shorter than I thought. It was only half an hour, but it's nice to do shorter content from time to time. Let's go back to Facecam. So I hope you've enjoyed this new content. If you have ideas for like other pieces of code that we see all the time in iOS, but we might not always know how they work under the hood, please let me know in the chat or in the comment, because I would love to do more content like this into the future. But I hope you've enjoyed this nice little content, and I hope that you have learned something new. If you're like me, an old iOS developer, I hope that you've enjoyed this little trip down memory lane, because when I started doing iOS, my first internship, it was back in, let me think, 2011. Yeah, 2011. So back then it was the days of the iPhone 4 and the first iPad. The second iPad was just released during my internship. Back then you were still using autoresizing masks. And even the year that followed, they were still being used. And I would say that Autolayout really started to pick up around like 2015, 2016. And then when the iPhone 6 and 6 Plus were released, then I guess it became like quite obvious that Autolayout was the way to go. So there are many developers that I'm sure have only seen Autolayout and had actually no idea of how this like struts and springs systems worked. So if I've given you like this nice, how should I say, like history iOS lesson, I hope that you've enjoyed it. I see some positive feedback in the chat, so it's really great. I also hope that you've enjoyed this new like lighting. I did some work yesterday to have some new lighting that also matches the color of the code. I tried to make it, and I think it looks pretty nice. I'm pretty happy with it. I will watch the replay to see if I'm also happy when I see the replay, but like that, I kind of like what I see. And I guess I just have to say thank you for attending this short live, and see you maybe not next week, but maybe see you in a few weeks or in a few days for another live, as soon as I have another idea for good content. Have a good evening. Have a good rest of your day. Bye bye.